Hi, today we are going to find out how to estimate the probability of death after inhalation of air contaminated with a toxic substance. So, let's begin. At first, we need to understand that one can't say what the exact consequence to individual organism will happen after inhalation of certain amount of contaminated air. This happens because each individual is different and the same dangerous toxic load will show different result on surviving of individuals. We discussed dangerous toxic load in a previous video, so please check it out. Now we understand that the same amount of toxin inhaled while breathing can result definite consequence. However, we can figure out what the probability of death exploring the behavior of certain amount of organisms. For example, we have 5 model insects. We apply on them contaminated toxic air with known concentration, let it be 1000 ppm, for 5 minutes. Then we see that 2 insects are dead, while 3 others have survived the experiment. Having this data, we can tell that the probability of death after taking this dose will be equal to 0.4. Imagine we have a set of experiments with variable concentrations and times of exposure. Then, using this set of data, one can figure out a so-called dose-response curve. Dose-response curve represents dependence of the probability of lethal consequences from dose obtained via inhalation. But we are going to use an easier probit approach. Probit is a probability unit and the probit function is a logarithmic one, which has 2 fitting parameters and a causative variable. In our case, causative variable is a dose or equivalent dangerous toxic load. Probit simply connects a dose with probability of death through function or special table. More about probability unit you can read by following the link in the description section. Now we just agree that probability unit connects the probability of death and dangerous toxic load. Using sets of data and approximation methods such as least squares, one can find the best suitable A, B and N coefficients which are appropriate for specific substance. Now we are just about to answer the main question: how to get the probability of death for a specific dose. Here is step-by-step instruction. Step 1. Set a problem. We need to be clear at what substance influence on human health we need to observe. For example, methyl isocyanate. What the gate of toxic substance incoming inside the organism, oral, injection in bloodstream, etc. We will look for inhalation. And what the concentration of toxic substance in air and what the duration of exposure, for example, 100 ppm and 10 minutes. Step 2. Look in a database for toxic properties of substance according to conditions in Step 1. Step 3. Write the data taken from the database. We have 2 dangerous toxic loads or doses and 2 probabilities of death. Step 4. Find probit values using special Finney's table. According to the table, the first probit, which corresponds to 0.01 probability of death, has the value 2.67, and the second probit, which corresponds to 0.5 probability of death, will be equal to 5. Step 5. Set a system of equations and find the solution. We need to find A and B fitting parameters of probit function. We can use such programs as MathCAD or Excel to solve a system of equations or do it manually. You can see an example of manual solution of system of probit equations. We have found both A and B fitting parameters and can just build up the probit function. Here's the result. Step 6. Find the value of probit for conditions described in step 1. Using the probit function derived in step 5, we are finding that probit equals to 3.50. Step 7. Using Finney's table and calculated in step 6 probability unit, we need to find out what the probability of death. Here's a table, and we see the closest value of probability unit is 3.52, which corresponds to probability of death equal to 0.07. So the answer for our question is, for a methyl isocyanate with a concentration 100 ppm and time of exposure equals to 10 minutes, the probability of death will be equal to 0.07. After such a research, you can decide how to protect people, environment, and effectively decrease the risk. Both process safety and quantitative risk analysis use a lot of those things. Well, it's time to take a break. Hope you enjoyed this video. Please follow to the description section for more information. Press like button and subscribe to my channel. Thank you for watching. See you.